Question is, how many times does 1 show up on each side? And each number only shows up once, right? Just one time. So there's some trick dices, or some different dices if you've played other games. This is just a regular dice where they only have 1, 2, and 3, and then they repeat 1, 2, and 3 again. Or sometimes they repeat 1 twice and 3 once. This is a very different dice. And then if you play D&D, then you know that there's 20-sided dice and so on. Very, very complicated, intricate dice. So yeah. But just for a regular standard 6-sided dice, the answer is just 1 over 6. 6 being the total possible outcomes, which are 6, and 1 being it's only one time does the number 1 show up. And in this case, because the regular dice is just pretty straightforward and it's fair, each number actually only has 1 over 6 chance of occurring. And if you want to convert that 1 over 6 into a into a decimal, get your calculator, input 1, hit the divide sign, hit 6, hit equal, and you'll get 0.1, and then you get a repeating amount of 6s. So I'm just going to stop at, I guess we can stop at 2 decimal places. I'm just going to round approximately 0.17. And if you want to convert that into a percent, times it by 100, and you'll get approximately 17%. Meaning approximately you have a 17% chance of any number coming up on this regular 6-sided die. Okay, what about Amy picking a card from a standard deck? So a deck of cards. Anyone know how many total cards are in a full deck of cards? I want an answer. Anyone? No one has played Cards Before President or Rummy or I don't know, Crazy Eights, Goldfish. Have you ever played with a pack of cards before? Do you know how many cards there are? No? No one? I'm waiting. Thank you, Mohammed. So yeah, 52. There's 52 cards in a full deck, as long as you're not missing any cards and you're not counting the jokers. So there's 52 cards. And the question is asking, what is the probability that she pulls an ace? Okay. We know the total number of possible outcomes is 52 cards. There's not 53 cards, there's not 100 cards, not 200 cards. There's only 52 cards in a normal full deck. How many aces are there though? Once again, I'm going to wait for someone to answer because this is, I think, common knowledge. Someone should know this. If not, Google it. How many aces are in a deck of cards? Oh, okay, good answer. Possibly. If you're not sure, if you've never actually played cards before or Crazy Eights or anything, or if you have, try to remember, there are 4 suits. There's a heart, there's a diamond, there's a clover. Oh, that was terrible, but that's okay. And then there's a spade. That's terrible. Anyways, so if you're not sure, there's an ace of hearts, ace of diamonds, ace of clubs, and ace of spades. There's actually 4 possible aces that you can have in a deck of cards. So the answer is 4. There's 4 aces. Now the aces aren't exactly the same, but that wasn't the question. The question was how many aces are there? And that's how you make your fraction. That's it. You just do the number of favorable outcomes, meaning the number of aces, or the total possible number of cards. So the answer is 4 over 52. And once again, we're going to do our writing in 3 different ways. So that's a fraction. Convert that into a decimal. Just take out your calculator, punch in 4, hit that divide sign, 52 equal sign, and you get a nice decimal of 0.077. I'm just going to keep 3 decimal places, be a little bit more accurate. If you have 3 decimal places there, all you have to do is now times it by 100 to get that percent. Times 100%, and the answer is 7.7%. And that's how likely it is for you to pull out an ace if it's a shuffled deck. But if it's not a shuffled deck, it's a brand new deck, you should know that depending on the deck, it's almost always, I think ace is like the first card, or it's either the bottom card or the top card. I can't remember anymore. But it's one of those things. So that also matters. You got to shuffle the cards. Otherwise, it's not really probability. Because you can cheat. You can just put the ace on top and be like, hey, well, 100% chance. Anyways, compound events. A compound event is an event that is based upon 2 or more trials conducted in succession. For compound events, we can use a tree diagram to analyze the possible outcomes. So what does compound events means? Basically, you're going to calculate the probability of something that's occurred and then do it again. There's an example here, you'll see. So you flip a coin 2 times in a row and use a tree diagram to determine the probability of getting heads both times. So how do you make a tree diagram? Easy. We know that a coin has how many sides? Excuse me. So you got a loonie or a quarter or whatever. There's 2 sides, right? There's the heads and there's the tails. So if you flip a coin, what are the chances that you're going to get heads or tails? I'm waiting for an answer. This is pretty straightforward. Hopefully anyone can either type in the chat or unmute and let me know. 1, close. So remember when we're talking about probability, the answer should either be in a fraction, a decimal, or a percent. So just be careful. Because when you say 1, that's actually equals to 100%. So you're telling me you can get 100% heads and 100% tails? So that's probably not true. So try again. You're close. It's 1 over something. There's a number underneath. So what are the chances? Well done. Thank you, Zara. Yes. So it's going to be 1 over 2. And if you're not sure how we got that, it's simple. You have a coin. And how many sides do you have on a coin? 2 sides. That's the answer. So the total possible things that can possibly happen are 1 of 2 things. And those 1 or 2 are either heads or tails. So heads gets 1 over 2, tails gets 1 over 2. Also, if you do the percentage, you'll know that this is 50%, 50%, which makes sense. Think about it. You have a coin, it's 50-50, right? That's why they say it's 50-50. I'm pretty sure this is not the first time you've ever seen a coin or you've ever flipped a coin. I'm sure you're in like grade 11. You must have done some of these things in your life before. So here we go. The trick here is now do heads and tails again. We flipped it. We flipped the coin twice. We flipped it once. We got either heads or tails. And then we flipped it again. We got either heads or tails. Right. So the question was now asking. Let's go back. What is the probability of getting heads both times? So this is the first time we flipped, and this is the second time. Now, the first time, if you get heads, we're good. And the second time we get heads, we're good. That's one path right there. One path of getting heads both times. Well, what if we didn't get heads? Well, we can get tails. Right? Boom. If we get tails, and the second time we get heads, that's a possibility. Also, we can get tails and then tails again. That's another possibility. Or we get heads the first time, and then we get tails the second time. That's another possibility. So the total number of possibilities is 4. 4. If you flip a coin twice, there's 4 possible outcomes. And I'll go over them again. The first time you can get a heads. The second time you get a heads. That's one possibility. First time you can get a heads, but the second time you get tails. That's another possibility. The first time you can get tails, and then the second time you can get heads. That's the third possibility. And then the fourth possibility is, well, you can get tails the first time and you get tails the second time. So total possible outcomes is 4 if you flip a coin twice. So that's 4 on the bottom denominator. And how many favorable or outcomes that you wanted? Like what did we want? We want heads twice. How many times can that ever happen? If you flip a coin twice only? Not if you flip a coin like 100 times. That's different. That's a different question. But if you're only flipping a coin twice, so there's only one possible way to do that, and that's getting heads both the first time and the second time. So that's 1 out of 4. And that's the answer. 1 out of 4. Or, obviously, if you write it as a percentage or a fraction, that's going to be 0.25 or 25%. Meaning the chances of someone getting heads twice in a row is 25%. That's how you do probability, and that's how you do a tree diagram. All right, now we have compound events. Another example, a woman has 3 children. Using a tree diagram to determine the probability of having at least 2 girls. So let's do that tree diagram, shall we? So we got a lady. She's going to have kids 3 times. So we're going to be like, okay, boy, girl. Boy, girl. Those are only 2 options, right? So when the baby's born. So we got 2 options, boy, girl, boom. Let's say, then, she's pregnant again. And the only other 2 options are boy, girl again, boy, girl again. And guess what? She's pregnant again. She has 3 kids. And the only 2 options are, once again, boy, girl. And then boy, girl. And you have to do that for every single previous option. You gotta split it up. So you can get a really big tree, like very fast. Okay, so to get the total amount of possible outcomes, you can count 1, 2, 3, 4, 5, 6, 7, 8. There's 8 possible pathways. Starting from here and then following the arrows, there are 8 possible pathways. Meaning the total possible outcomes are out of 8. But now the question was, she wants to have at least 2 girls. So which pathways gives the lady 2 girls? Well, let's see. First, let's say she has a boy. Okay. And now she has a girl. And then she has a girl. So pathway 4 is one possible path to have at least 2 girls. She has a boy first, and then girl. Okay. I will do yellow. What about any other pathways? Are there any other pathways in which she can have 2 girls? Well, if she has another boy, girl, and then boy. That's two boys and one girl. That doesn't work. She has boy, boy, boy. Obviously